Welcome everyone, welcome students. First of all, welcome to all of you on behalf of GATE Academy. And see, we are going to be discussing about signals and systems today. So signals and systems is going to be very important topic for ECE, EEE and IN guys. And it's a very interesting subject and very concept oriented and very beautiful subject. So let us look at the top expected questions that we are expecting from the signals and systems for this year GATE. Okay, so these are the few important areas. We have looked at it based on the analysis of the previous, say, 30 years of GATE papers across various disciplines, and we have come up regarding key concepts of this topic called signals and systems, which will be very useful for the aspirants, GATE aspirants. Okay, so welcome all the best. Let's get started. So we are starting with signals and systems. Here comes the first question. It's a MCQ type of question. Okay. So So anybody wants to attempt this question? Anybody wants to share any opinion about this question? How to go about this? Anyway, the answer is also displayed in the along with the question itself. But anybody wants to take a quick guess at how to approach this question? The answer is anyway given along with that. Any question, anything? Okay, let me ask you a question before even we go into this question. X of t equal to sine pi square t. Is this periodic or not? Anybody? Any take on this? Is x of t equal to sine pi square t periodic or aperiodic? Tell me, what's your opinion on this? The answer is it is periodic. All sine omega naught t are periodic. All sine omega naught t are periodic. But sine omega naught n is periodic if and only if 2 pi by omega naught is rational. Because this is a discrete number. See, there's a very beautiful thing you need to understand. Here we are in the continuous number system. When you're in continuous number system, rational number, irrational number, this number, that number, every number is part of that. Odd number, even number, rational number, irrational number, root of 3, root of pi, everything is part of this continuous number system. The entire real line is part of this number system. Whereas when you are in the discrete, this is discrete number system. When you are in discrete, only numbers which are rationalized, which can be expressed as a rational number, only can be discretized. An irrational number can never be discretized. And pi is an irrational number. Pi is 22 by 7 only in your school days. Once you are out of your 10th standard, pi is no more 22 by 7. Pi is 22 by 7 is an approximation. So sine pi square n is there. So here omega naught is pi square. Omega naught is pi square. So 2 pi by omega naught is 2 pi by pi square, which is 2 by pi, which means irrational. If 2 pi by omega naught is irrational, the signal will be aperiodic. This concept has been exploited in GATE multiple times. Please note, I will quickly list down all the concepts related to this question also. E power j omega naught t, sine omega naught t, cos omega naught t are always periodic. Whereas their counterparts in the discrete domain, e power j omega naught n, sine omega naught n, cos omega naught n, they are periodic if and only if 2 pi by omega naught is rational. If 2 pi by omega naught is rational, then you can find the period. Correct? Clear? This is very important. Please keep this point in mind. This is very, very important. Multiple times this concept has been exploited in GATE. That's the reason we are covering this as one of the important concepts for GATE. Now, which of the following signal cannot be a Fourier series expansion of a periodic signal? This is again a very, very beautiful question. You have a Fourier series expansion of a periodic signal. So what cannot be the Fourier series expansion of a periodic signal? That's what is being asked. And why it so is more important. Now, let us look at the trigonometric Fourier series. So how the trigonometric Fourier series will look like? X of t is equal to a naught plus summation n equal to 1 to infinity an cos omega naught n plus bn sin omega naught n. This is how the trigonometric Fourier series will look. Correct? This is the trigonometric Fourier series. Correct? If you are looking in terms of complex Fourier series, x of t will be summation n equal to minus infinity to infinity cn e power j omega naught n. This is complex Fourier series. Correct? This is the complex Fourier series. This is the trigonometric Fourier series. So clearly, the Fourier series will have a DC term. So this is the DC term. These are sine terms and cosine terms. So how that sine terms and cosine terms are repeating? Sine omega naught n. Sine omega naught. So n is varying from n1 to infinity. So sine omega naught, sine 2 omega naught, sine 3 omega naught, sine 4 omega naught. So all the integer multiples of omega naught will be present. Similarly, cos omega naught, cos 2 omega naught, all the integral multiples of fractional multiples of omega naught may not be present, but integral multiples of omega naught will be present. See guys, this is the beauty of GATE problems. All the GATE problems will be cunningly worded. There will be just a crisp of the concept. Many people, they thought this is the answer because here we are having fractions. No, that is not the point. The point is omega naught can be anything, but integer multiples of omega naught will be there. So if I look at this, what is this? This is 3 pi by 2 t. So your omega naught is 3 pi by 2. So after 3 pi by 2, this is omega naught. So again, integer multiples of omega naught. So if I see 1 by 2, then 2 into 1 by 2, 3 into 1 by 2, 4 into 1 by 2, 5 into 1 by 2, 6 into 1 by 2, 7 into 1 by 2. All these are integer multiples of 1 by 2, correct? So if you see 3 pi by 2 is a integer multiple of 1 by 2. Similarly, 3.5 is 7 pi by 2, which is an integer multiples of 1 by 2. And certain Fourier coefficients can be 0. Certain Fourier coefficients can be 0. So this very well can be a Fourier series expansion of the signal. This is the DC term. And here the omega naught is 1. So this can very well be the Fourier series expansion. So if you see cos t, so if cos t is there, cos 2t, cos 3t, cos 4t, cos 5t, all these components can come in the Fourier series. The other frequency component, if they are not present, their Fourier coefficients may be 0, so they are not present. So this is also perfectly fine. But if you look at this, this is cos pi t. So I should have integer multiples of pi. So 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, like that it should go. Or I am having cos t. That means omega naught is 1. So I can have integer multiples of 1. 1, 2, 3, 4, 5, 6. So now pi and 1 are not integer multiples of one another. Pi and 1 are not integer multiples of one another. Correct? So B is the answer. Many people got confused that D is also the correct option. Because many people know that there can be a DC component in the Fourier series, and cos t, cos 3t. So that's fine. So, and many people also mug this concept that integer multiples of omega naught is allowed, but fractional multiples of omega naught is not allowed. So here this looks like a fractional multiple of omega naught. Many people went and ticked this, but this is not the option. This is the option. I hope this is very clear as to see, guys. More important than knowing what is the answer, it is equally important to know what cannot be the answer. This will be very handy for you in making judgments. More than what is the answer, you should also know why something is not the answer. Here, why this is not the answer, you should be very clear. Clear? So we discussed 2 questions so far. Let us go to the next question. This is another beautiful question. Tell me how to approach this. There are 2 real sequences, x1 of n and x2 of n, given by this. x1 of k and x2 of k are be a 4-point DFT of x1 of n and x2 of n, such that x3 of n, DFT of x3 of n is x3 of k, and x3 of k is x1 of k into x2 of k. So what they are saying, I am having a signal called x3 of k, and in the frequency domain, x3 of k is looking like x1 of k into x2 of k. And what is being told to you? x1 of n on DFT becomes x1 of k. x2 of n on DFT becomes x2 of k. x3 of n upon DFT becomes x3 of k. Correct? And also they have told that this is, so clearly we know multiplication in frequency is convolution in time. Correct? That is x DFT of x3 is x3 of k, and x3 of k equal to x1 of k into x2 of k. So inverse DFT of x1 of k into x2 of k is equal to x3 of n. If I take inverse DFT on both sides, I will get x3 of n. But by convolution theorem, inverse DFT of this is nothing but x1 of n convolved with x2 of n by convolution theorem. Basics, all basic, just basic. That means I have to just take the convolution. I have to just take the convolution, correct? Excuse me. So I have to take the convolution. So let us take the convolution. So how do I take the linear circular convolution? Here I have to take circular convolution. Kindly note, whenever I am dealing with DFT, many people see, these are the very important things. People know multiple things, but they make silly mistakes. They will come to convolution and they will take linear convolution. Many people I saw making this mistake in this problem. They very rightly identified that they have to take the DFT, they have to take convolution, but many fell the trap. When we are using DFT, the convolution is circular convolution. Please don't get confused. It is going to be circular convolution. Okay? Don't take linear convolution. Many people identify this correctly, but they fall trap and take circular convolution. So how do I take circular convolution? This is what the symbol for circular convolution, right? So how do I take circular convolution? Tell me. Yes. So they are circular convolution and linear convolution, both are commutative. So x1 convolved with x2 and x2 convolved with x1, both are one and the same. Rotate this and write it in a matrix form. So 1, 2, 3, 0. 1, 2, 3, 0. Then 1, 2, 3, 0. 1, 2, 3, 0. I just rotated it. The 1 is here, the 1 came here, the 1 came here. That means the rows, the column The first column, I just rotate it and write the second column. The second column, again I rotate it, write the third column. Third column, I again rotate it and write the fourth column. Correct? This I have to write it such that I can do the matrix multiplication. That many times I have to replicate it. So 1, 3, 2, 1. So now 4 rows are there. So 4 columns, 4 rows. I can take the matrix multiplication. So 1 plus 0 plus 6 plus 2. This means 9. 2 plus 3, 5. 0, 5 plus 3. 8. This is 9 over here. 1 plus 3 is 6. Sorry. 1 plus 0 plus 6, 7 plus 2, 9. Correct. 2 plus 3, 5 plus 0 plus 3, 8. 3 2s are 6, 9, 11, 0. So this is 11. Then 0, 3 3s are 9, 2 2s are 4, 39 plus 4, 13, and 14. So we have to take only x of x3 of 2. So if you are smart enough in gate, I solved it for completely. We clearly know this is 0, this is 1, this is 2, this is 3. If you are smart enough, you need not do all these things. 2 is going to come in the third entry, so you can directly take the third row and multiply here. That's it. Okay, you need not even find these things in gate. For gate, you need not waste your time finding all these things. 11 is the answer. Directly you can write it. So answer is 11. So since it's a numeric question, it's given with a range. So in gate, just for highlighting this concept, I solve the problem fully. But when it is coming in gate, directly write this matrix. 1, 2, 3, 0. 1, 2, 3, 0. 1, 2, 3, 0. 1, 2, 3, 0. And 1, 3, 2, 1. I am being asked to find x of 2. So I don't bother about these 3 values. 3 plus 6, 9 plus 2, 11. That's it. This is the answer. Don't waste time for computing this value because that is not needed. Okay? Good. I hope the session is going fine and you guys are enjoying these problems. So far, you have seen some very good problems. 3 problems, very interestingly, we have seen. This is the 4th problem. Anybody wants to guess how to solve this? This is again going to be very interesting. Already the answer is getting displayed, but don't go by the answer. Think. See, e power minus t is given. So e power minus t, how it will look like? Then e power minus t, how it will look like? Correct. Delta of 2b minus 2. Delta of 2b minus 2. Where it will be? Tell me. Dirac delta function d 2b minus 2 is there. How will you get Dirac delta function delta of 2d minus 2? Tell me. Please tell me how will you get this? Yes. This is correct. Then what you will do? Okay, before that, that's an interesting question. Here in this problem, I have a scaling, I have a shifting both. How this signal will look like? So delta of t, let's say for example, delta of t looks like this. Delta of t is like even signal. So it looks like this. Around 0. This is my 0. So this is just some minus 1 by a to 1 by a, and the value is, or rather, minus a to a, and the value is 1 by a. That's how we get the Dirac delta function. Correct? Minus a to a, and limit a tends to 0. Correct? So it's like a small spike. So a is so small, so 1 by a will be a very large spike from minus a to a. So delta is even signal. This is how delta function looks like. So delta of 2t minus 2, how it will look like? Tell me. What I should do first? Either I should scale first, or I should shift first, or I should shift first and then scale. So delta of t, I should shift first. We get delta of t minus 1, and this on scaling will become delta, or sorry, t minus 2, and then I can do delta of 2t minus 2 on scaling. Correct? Or if you are scaling first, you should be scaling twice and shifting by 1 unit only later. Okay, because the time scale got manipulated. Okay, delta of 2t minus 2. So first I have to shift and then scale. Correct? So if I shift this, this will become a 2. This is a 2. So again, minus a to a, 1 by a is the value. So this is looking like this. Correct? Correct? Then what will happen? Think about this. Clearly, you are doing an integral minus infinity to 0. When I am doing an integral from minus infinity to 0, the delta of 2t minus 2 is existing on the RHS. So I am integrating on this side. This is my minus infinity to 0. This is my plus infinity. Correct? Now, when I multiply these two signals, the other signal is 0 everywhere. The other signal is 0 everywhere. The other signal is 0 everywhere. This is my e power minus t. My delta of t looks something like this. Wait, let me change the color. This is my e power t, right? My delta of 2t minus 2 is somewhere here. And it is 0 everywhere. Now, if I multiply these signals, what will I get? I will get 0 everywhere. So let me draw the output, how it will look like. I'm going to multiply these two signals first, correct? How that result will look like? That result will be 0 everywhere here. And it will get some value here. And 0 everywhere. In this interval, it will pick this value. But I am least bothered about whatever value it is picking here. For me, the worry is minus infinity to 0. Minus infinity to 0, this function is simply 0. Because this function is simply 0, if I integrate this also, I will get simply 0. That is the answer. It's a very beautiful question. Clear? Suppose I want you guys to think about this. Suppose if I do integral minus infinity to infinity e power minus t delta of 2t minus 2 dt. What will be the answer? Just I want you guys to try this out. If I do integral minus infinity to infinity e power minus t delta of 2t minus 2 dt, what will be the answer? And answer, look at that answer and look at the problem statement here. Something it is going to give you a clue. Okay, look at, try this as a homework. Please, I request you to try this out as a homework. Integral minus infinity to infinity e power minus t delta of 2t minus 2 dt. Try it out and see what is going to happen. Okay. Okay. Let us go to the next problem. This is another beautiful question. Let me move this from here. Okay. So consider a causal linear time invariant system. Causal means what? Why this word causal is given? Can anybody think about this? That's a very beautiful point. A causal LTI system characterized by the differential equation is given by dy by dt plus 1 by this. That means I can find the transfer function because h of t is 0 for t less than 0. That's what it means. Causal means h of t equal to 0 for t less than 0. It's a very important point. Now, let us look at the transfer function. Now I can take the Laplace transform on both sides. Now, how the Laplace transform will look like? S y of s plus y of s by 6 is equal to 3x of s. So y of s is 3 times x of s divided by s plus 1 by 6. This is what I'm getting. And they're asking what is the response of the system to a to an input 3 e power minus t by 3 u of t. So what will be x of s? X of s is 3 e power minus t by 3. E power minus t by 3. So Laplace of e power minus a t u of t is what? 1 by s plus a. So this will be 3 by s plus 1 by 3. So this will be, this is implies y of s is equal to 3 into x of s. So x of s is what we have written here. X of, so 1 by s plus 1 by 6. That is this thing into 3 by s plus 1 by 3. So 3 can be brought out. So this is 9 times 1 by s plus 6 into 1 by s plus 1 by 3. Now, solving this problem, this problem has to be thought about. Now, in gate, we need to be cautious about time also. So if I split this into partial fraction, how this will look like? If I split this into partial fractions, how this will look like? 9 times a by s plus 1 by 6 plus b by s plus 1 by 3. This is how it will look like. So it will be 9 times a e power minus t by 6 plus b e power minus t by 3 u of t. So first thing is I should look at whether am I lucky enough to get any option like this. Definitely this is not the option, because there is a e power minus t by 6 option also, e power minus t by 3 option also, and clearly a cannot be 0. If I look at this partial fraction split, clearly a cannot be 0, because if a is 0, I'll get only s plus 1 by 3 fraction, but in the original polynomial or the original response, I'm having both s plus 1 by 6 and s plus 1 by 3. Both the terms are present. Correct. So definitely this cannot be the option. Let me look at this. So I'm having 9 times a e power minus t by 6 plus b e power minus t by 3 u of t, where I got y of s as 9 times 1 by s plus 1 by 6 into 1 by s plus 1 by 3. This is what we got, correct? So now definitely this also cannot be the option. Here I am having a t power 9 e power minus t by 3 and 9 e power minus t by 6. And here also I am having a e power minus t by 3 and e power minus t by 6. So I need to be careful now. I need to be really careful now. So whether it has to be one among C or one among B. So we have, now let me do the partial fraction. Otherwise there is no need to do the partial fraction itself, correct? So if I do the partial fraction now, what will I get? So this will be split as 9 times. So how will you do the partial fraction? 1 by s plus 1 by 6 into s plus 1 by 3 is a by s plus 1 by 6 plus b by s plus 1 by 3. So at So what will happen? 1 is equal to A into S plus 1 by 3 plus B into S plus 1 by 6. This is what we will get. So at S is equal to minus 1 by 3, B will be equal to 6. At S is equal to minus 1 by 6, A will be equal to minus 6 if you simplify this. Because when S is minus 1 by 6, this term will go away. Minus 6 plus 1 by 3 will be plus 1 by 6. So, correct. And if you see the other way around, at S is equal to minus 1 by 3, B will be minus 6 and this will be plus 6, correct. When S is minus 1 by 3, this will get cancelled away. Minus 1 by 3 plus 6 will be minus 1 by 6, correct. Minus 1 by 6 plus 1 by 3 is same as minus 1 by 6 plus 2 by 6, which is 1 by 6. Correct. That's what we got. So A by 6 will be 1. So A will be 6. So now we got this option. So it is A and B both are 6. So 6 can be brought out. E power minus t by 6 plus e power minus e power minus t by 3 u of t, which is 54 times e power minus t by 6 minus e power minus t by 3 u of t, which is this option. 54 e power minus t by 6 minus 54 e power minus t by 3 u of t, which is this option. So all these 5 questions, these type of questions are very, very, very common in GATE. We have picked these 5 problems. I repeat, looking at all various previous year GATE papers, and I hope this session uncovered a lot of useful insights into you. Like, look at the variety of concepts covered. E power j omega naught t is periodic always, but e power j omega naught n is conditionally periodic. Then, look at the problem, all the problems. Let me quickly rephrase this one. Then this is another beautiful concept. Many people take the bait thinking that integer multiple of omega only should be present, fractional multiples of omega should not be present, but that does not mean that this number cannot be fractional. This number can still be fractional, and an integer multiple of a fractional number can still be a fraction. That's what is the concept covered here. That's a very beautiful concept again. Again, in this problem, 90% of the people come to the conclusion that the convolution needs to be taken, but people get confused between linear convolution and circular convolution. Whenever DFT is there, circular convolution should be taken. That's another beautiful concept covered. And here, the function, how the Dirac delta function looks like, and how I am taking the integration, whether the function exists in the region of my integration or not. Accordingly, the answer will be very straightforward. And then here, based on Laplace inverse, this is a very, very standard problem based on inverse Laplace. Like this type of questions are very famous with Z transforms also. So given, they would have given you the difference equation. Instead of a differential equation, they will give you the difference equation, and they will give you the discrete input x of n, and they will ask you to find y of n, where you will be, instead of taking Laplace transform, you will be solving at that time by Z transform. Okay. So this is very, very important. So all these concepts, I hope the concepts covered are very clear here, and we will like to hear from you. Please share your feedback and call us on this number, visit the website and share your feedback here. Okay. Wish you all the success, guys. Wish you all the best. Okay. Thank you. Thank you. I think somebody is saying something. Okay.